Good day everyone, I am Von Lemor Arquetas. I am IT 124 and I will be teaching CALENG1 Differential Calculus quiz number 1. So the introductions that I will discuss would be about functions and limits. Now let's talk about functions and limits. So limits basically describes how a function behaves near a point instead of that certain point. So function, if you can recall, is a system set of voided pairs where the x value is independent to the y value. So that is denoted as the f of x, which is the y, is the function. So the x value is independent, so if the x value is 3, then the f of x would be 3 plus 1, which is 4. So that's a function. I want to talk about the greatest integer function. Basically is the greatest integer of a certain point to the left. So let's say, what is the greatest integer of the 3.2? That will be 3. The greatest integer of negative 1.5 would be negative 2. Now let's move on to solving some limit problems. So limit is denoted as the limit of f of x as x approaches a. So limit of f of x as x approaches a is equals to L. So let's solve this problem. What we can do here is we can see that if we directly substitute this x as it approaches 2, the denominator will turn out to be 0, which will be undefined, and we cannot have an undefined limit, or it will not exist. So what we'll do here is we can factor out the numerator, then we can cancel. So that will give us the limit as x approaches 2 is x minus 2 times x minus 2 over x minus 2. So we can cancel this, and well, what's left is the limit of x minus 2 as x approaches 2. Now we can directly substitute and it will just result in 0. So the limit of the problem is 0. Now let's answer one-sided limits. One-sided, it basically means the limit approaches a certain number very close to that number. So it approaches 4, positive means it's from the right, so it's greater than 4, but it's very close to 4. So like, yeah, okay. What we can do here is we can directly substitute this, because even if the denominator leads to 4, indirect substitution leads to 0, the denominator, it will not be actually 0 because it's from the right hand, so it's gonna be 0 positive. So let's demonstrate. If we substitute this, it's going to be 4 plus 2 over 4 squared minus 16. 4 squared minus 16 is 0. 4 plus 2 is 6. 0 is denoted as very close to 0, but greater than 0 because of it's from the right hand. So 6 over 0 positive is just equal to positive infinity. Now let's answer infinite limits. Let's try to directly substitute this problem. So we can see that the limit of 5 over x minus 2 squared times x plus 4 over x minus 7 as x approaches 2 from the left, because of the negative sign. So if we substitute this, it's going to be 5 over 2 minus 2 is going to be 0 squared times 2 plus 3 is going to be 5, and 2 minus 7 is going to be negative 9, negative 5 rather. So this would be a negative, so negative times negative is going to be positive, so that's equals to positive over positive times positive 5 here over negative 5. So what we can see is positive times negative, it leads to negative infinity. And that's the limit. Now we have infinite limits, which is here. This is negative infinity. And we have limits at infinity. So those two are different. What we can see here is, we can see the answer right away. We just have to look at the greatest degree of the function. That would be x to the power of 7. So if we take a look at that, we can see that we can ignore all of these lower degrees. We can just focus on the greatest degrees, which is this 2x to the 7th over 6x to the 7th. So the answer is 2 over 6, or 1/3. We can solve that by just dividing everything by x over 7, x to the power of 7. So like 2x to the power of 7 over x to the power of 7 is going to be just 2 minus 3x to the power of 4 over x to the power of 7 plus 5x over x to the power of 7 minus 1 over x to the power of 7 of 7. We can cancel this into 0 because a numerator divided by infinity is 0. So those are all 0 except for 2. So we can do the same thing about the denominator here, which is 6x to the power of 7 minus, divided by x to the power of 7 is just 6, plus 5x to the 5th over x to the power of 7, again this is 0, minus 2 over x to the power of 7, which is another 0. So what's left is just 2 over 6. So the limit as x approaches positive infinity is equal to 1/3 because of 2 over 6. So that's the lowest term. Now let's move on to squeeze theorem. So it's basically these two. The most important concept of squeeze theorem is these two. So sine x over x is equals to 1, and 1 minus cosine x over x is equals to 0. So let's answer this problem of sine x over x. We can see here if the the answer is going to be 0. Well, I can say that because, well, if we are trying to find this in this, we need to have an x numerator and the x denominator, and the x is stuck in that squared sign, so we need to multiply it by x over x. So we can shift these two, which will lead to sine x over x times x over 3 square root of x. So this is just 1, as per the squeeze theorem. So what we're going to do now with the remaining is we're going to rationalize it to remove that square root of x. We cannot have a square root at the denominator. So times square root of x over square root of x. So this is still 1. So that will give us an answer of x square root of x over 3x. Now we can cancel the x. This will give us square root of x over 3. So the limit as x approaches 0 just equals to, we can directly substitute this. The square root of x is 0. The square root of 0 is just 0 over 3. So the limit is just equals to 0. And our last topic is going to be continuity. So continuity is basically, it has to meet all 3 criteria. So if one criteria is not met, it's automatically a discontinuity. So continuity is a function is defined. It has to be defined. So, and the function is equal to the limit. So the limit must exist. So let's take a look at this graph. As we can see here that this portion is discontinuous to this portion as the left side approaches a coordinate of -4, 3. Let's note that. And the right side meets at -4, -2. So the function, it exists, it's defined. The limit is not existent because of the different points. Therefore, this is discontinuous. Unlike this one, where they both meet, the left hand and the right hand both meet at -1, 4. This is continuous because the function is defined, the limit exists as -1, 4, and the limit is equal to the function. So you can actually tell by graphing whether the limit exists or not. So the limit doesn't exist in this one, and the limit exists on this one. Now, as per vertical and horizontal asymptotes, the limit does not exist as it is both on infinity. So it reaches the positive infinity here for the y-asymptote or the vertical asymptote. From the right hand and from the left hand, it's reaching negative infinity. So that's that.
Thank you so much for watching. You may also avail syntax tutorials and materials by scanning the QR code that is flashed on your screen. So once again, I am Voldemar Cortez from Syntax, paving your way through excellence.